first to make sure it's.
Okay, we have a 16 inches.
Actually,
See,
yeah,
yeah, it's a 16 inches. Given the form factor. This one, see the back screw already taken out, which is the back cover has already been taken out. Okay, this has also no screws. Okay, this one screws has been taken out.
Please just shut down. Yes.
Okay, there are no screws at all. What's the issue of this one again? Is it a no power? Okay, so this looks like.
How's about bring tomorrow? I'm in Cape Town. Okay, bring it tomorrow.
Okay, so this looks like a machine that was disassembled and the board was left out of the shelf for some time, and or maybe this is a client's DIY kind of stuff where they decide to, because it's the company that sends this, they don't remove, even if they do remove the screws, they will put them back after assessment. So the fact that it's coming in like this, I mean, it's either coming from the client or it's been somewhere from the client. Okay, whatever the story is, this is not starting. So let's go through the initial measurements on the 16 inches. So because it's a 16 inches, our primary concern will be the NAND circuitry, and we can start by checking what is it that we have on our PP bus line. That's these two fuses are sitting on our PP bus line. So let's see if we have a short on PP bus. Okay, we don't have a short on PP bus. The next thing we're going to do is to check to see if I have a short on a 2.5 volt line on the right. Okay, not really. And then the left. Okay, we don't seem to have. Okay, we don't seem to have a short on either side. Okay, so let's connect power to it. Let's now connect power to it. Let's see what is it that we have on our PP bus. That will give us an idea what's happening on the board. Let's see what's happening. Let's see what we get on people. Okay, finally starting. Interesting. It's a no backlight issue. Can you see that? It's actually not a no power. It's a backlight issue. Okay, so let's. Did they say it's water damage? Oh, I was asking you if it's a no power. I said it's a no power. So it's a no backlight. It's not a no power.
Does it matter? This is underneath on top.
No, it has to be on top.
Because I'm gonna stick shit and run. Yeah.
If I walk with you, I'm gonna go into the side. Eh? If you walk like that. Okay, so I was asking if it's a no power. I said it's a no power. So it's actually okay. So let me get another screen quickly. Do you have any 16 inches that the shell is out? Okay, it's fine. Before I even do that, we can just see what is it that we have on our backlight output. So it's not a no power. It's yeah, but I was asking you, and then you said it's a no power. Okay, let's see what is it that we have on our backlight output. So these capacitors here are what's sitting on our backlight output. So in order for us to check for that, we have our there's no power on it because we are going to do measurements on diode mode. So right in this case, red probe is going to be on ground, and then black probe is going to be on this location. So let's see, that is 0, and then the other side is 0.082. So we have a problem. So that is too low for the backlight output. So that's not supposed to, so we're supposed to have 1.1 1.112 something, not 0.082. Now, so the next thing we're going to do is so now that we see that we definitely have a short on this side on the PV board on the backlight output line. Let me just quickly open up the board view, show you guys. This is an 820.00700, 01700, I suppose. It is yeah 01700. So we not having backlight, we check in the backlight output, which is on this line here. Where it says PPV out underscore so backlight output. So we do so because what we have on our backlight output will determine where we go from there. So we're using our diode mode measurements, and then you can clearly see that we have a very low reading on the backlight output. I'm gonna get another board to show you that we're supposed to get way higher than that.
Solar charging.
No, you have to put in the battery. You have to put in the password to see if it's charging. You won't be able to.
But doesn't
You do not indicate from there.
No way, man. No way, but I've been done cheating 3 times like this. Why isn't it?
You see this small knowledge, you see those small things. He's gonna stress his life out thinking the machine has a problem. You see, when I tell you these things, you don't understand how important those small things are. You see, so we're supposed to get 1.2 something, not what it's getting. So this is definitely low. You see that 0.08 something. So that's definitely low. So the next thing we're going to do is that we want to confirm if the issue is coming from the main board. We hope so, and not the screen, because if it is the screen, that's going to be a bit of an expensive repair. How do we confirm that? We will disconnect the cable from the screen. We disconnect the cable from the screen, and then we measure again. So if the reading returns to normal, then it means the problem is from the screen. But if the reading is still okay, it's still the same, it means the problem is from the board. So let's see. Let's hope that it is on the board because it becomes less expensive. Okay, alhamdulillah, the problem is still there. Screen is disconnected and the problem is still there. So definitely the problem is not from the screen, but it is from the board. Now, usually when you have an issue like this one, where you have a low reading on your backlight output, which is because you don't have backlight. 9 out of 10, it is one of these capacitors. So when I say one of these capacitors, I don't mean, because there are two sets on both sides. So you have this set, and then you have this set. So it's one of them has failed. So we now have to figure out which one has failed. And then again, so the way you want to do this is after, and this is also if you have in a situation like now, it will be different if the device itself is liquid damage, for example. Then you want to say if there is a region specific where you have liquid on. But other than that, if you have a similar issue just like this one, you have no backlight. But before you want to make sure that the screen is disconnected to confirm that the issue is narrowed down to the board. Check for your backlight output, and then there's something else. Now with this one, you might not be able to catch it with a multimeter. I'm just going to check if you set your multimeter to continuity mode. So here will beep, and then the other side, see that it doesn't beep. So even though it doesn't beep, understand that the reading is very low. You can always confirm that, which is also why I usually will mention that even though you don't get a beep, you also want to look at the digits that you get on your output. So so if this is not only going to be specific to 16 inches, it's the same thing with the non-touch bars, the touch bars, the 13 inches, the 15 inches, the 16 inches. It's practically the same thing. When you have an issue like this one, disconnect your screen, check to see what is it that you have on your backlight output. If you have a short, that's a good one, because it means that the problem will not be as extended as if you don't have a short. So if you have a short on your backlight output, it's pretty straightforward. How do you do it? You can just remove all of the capacitors, all of it, one by one, and then check to see which one is faulty, and that's it. So you can start by sometimes you can actually look, and then you'll be able to actually pinpoint which one has failed. But other times you can just easily remove one set, measure again, nothing happens, measure the other set, and it's just as simple as that. So this is a pretty straightforward, which is what we are going to do. So I can just go ahead and I can go ahead and look to see if any of the capacitor it's a bit discolored in any way or anything that could suggest that this is a failed one. But I'm not going to do so for the purpose of this video. I'm just going to go through the manual way, uh, which is to just remove the capacitors from remove it from one set and then the other set, and then that way we'll be able to figure out exactly where the failure is. Like I said, this is not peculiar to 16 inches. So even if it's whether it's a touch bar or non-touch bar, if you have a similar issue like this one, this is the way to go about it. Okay. So we are gonna choose to either from the top or from the bottom. So what we can do is we can start from the bottom. So there's one thing we can do, which is we can just remove the entire line and then measure, or we can take out one by one and measure. So whichever, so whichever you want to do, you can do. So if you want to be very quick, you can just remove the entire tire and then you then measure one by one. But which is both sides are equally quick, which is because if you take out everything, you mean you have to put everything back again. You have to say, so you can choose to say, okay, take one, and sometimes you can be super lucky that the first one happened to be a problem. And mind you, when you look at it, when you by just looking, you might not really be able to say that okay, this is one, because they will look all the same. So oftentimes the one that has failed, you will probably see the discoloration from the other side. So when you remove the capacitor and then you flip it the other way around, and sometimes you might not see anything that suggests that this is the one that has failed, even though it has internally failed. So we're just going to start from the side, and I'm going to do the other way, which is just remove everything at once, and then we'll measure. So because we know these are capacitors, we are not supposed to have a reading across them. So what I'm going to do while I'm waiting for my board to cool off, I'm just going to do this to see if anything, if I get any reading across, which will quickly tell me that that is my problem. Okay, so none of this is our problem. So which means we'll still have a short on the board. So 002, and then the other side should be 0. No, actually the short is gone, because now that's going to increase. Yeah, the short is gone. Yeah, the short is gone. So yeah, the short is gone. However, the capacitor that has failed, it's so subtle. That's the one. You see, this is the guy that failed. And interestingly, the first time we checked it, we didn't pick it up. So that's the one that failed. You see, 0, 0. Now, if you ideally, you're not supposed to get any reading across it. You see that? Because it's a capacitor, you're not supposed to get any. Uh, you're supposed to have complete resistance, but in this case, you're having. So if we flip it, so I'm not sure, I really doubt you guys can see that, but if you look at, I don't know if you can see the way, see the way it looks. Can you see it? Now on the other side, you wouldn't be able to pick it up, but here you see how it looks on that side. I'm not sure if you can see it. Can you? Can you see it? It looks.
Let me see exactly.
Yeah, it looks different. Let me see if I can. If I place it here, maybe. And if you see the other side, there is no marking. It's straight. But this side, See those marks? See the way it looks? Yeah. Anyway, it might be difficult to, but that's our problem. So we are now just gonna put the rest back, and that's about it. It's just how you adjust an issue like that. And now, if you don't have a replacement, you don't have to worry. But in our case, we have too many of it. So too many of it. It doesn't have to be from. It doesn't have to be from a 16 inches. It doesn't have to be the same machine. You can take from 13 inches. You can take from 16 inches. You can take from 15 inches. They're all the same. So if you don't have a replacement, you don't worry. Your device is still going to work. But in our case, we have too many of it actually, not just we have too many of it. So we are going to place it back. So if you happen to have a short in if you happen to have an issue with a backlight with devices from 2016, let me just confirm, if 1502, if they use the same. So it's F1502 did use the same thing, but it is from 2015, not 2014. 2013, 2014 uses a different configuration capacitors. Let me just see, and let me see. Okay, so these capacitors you can find from 2015, A1502. So these are the capacitors. See them? So you find them on 2015, you find them on 2016 MacBook Pro, touch bar, non-touch bar. You find them on 2017, 2018, 2019, A15. You also find them on A1707, A1990. You will find them. You will find them on M1 13 inches, MacBook Air. You will find them on the Intel. This is an Intel 2019. You will find them on this is 2020, 4 ports, Intel, still they are there. This is 2018, 2019, you see, it's the same thing that is used. M1 Intel, what am I saying? M1 Airs, you'll find them, and also M1 Pros, you will find them. So you see that this is an M1 Pro and this is an M1 Air, same capacitors. So you have lots of options for them. So the difference would obviously be the 16 inches, and then as well as the 16 inches M1, M2, and the 3, and 14 inches M1, and the rest. But 13 inches, all are the same thing. Which other one did I not show? So this is the non-touchable, as you can see. It's the same capacitor. So there's lots of it. The 2013 2014. Let's see. So the 2013 2014 1502. You see, it's different. So they use a different. Uh, See, you cannot find those capacitor combinations. This is 2013 2014. But from 2015, this is 2015. From 2015, they started to use that on their backlight output. Okay, so yeah, so that's that. In case you're looking for replacement. Um, uh, okay. And by the way, it's worth noting that the 15 inches A1398, they don't use the same capacitor. They don't use the same capacitors. The 15 inches A1398. But yeah, there's plenty of options for you for replacement. So we are quickly going to clean that. And also, please note that before you blame the capacitors, yes, the capacitors, especially for backlight issue, it's a common failures. Those capacitors, they fail. But before you blame them, make sure you disconnect the screen and check again. So, because sometimes you have a case where the problem is coming from, the short is coming from the screen and not the cap. But yes, the capacitors, they are they commonly fail. Oftentimes, it's just one of them. Sometimes you get more than one, but that's very rare. Most of the time, it's just one that has failed. Okay, let's see what we have now. Let's quickly test the board as well. Okay, we are only going to connect the cables that we need for testing. Uh, okay, and that's about it. So screen, trackpad cable. Even though we don't need that, but yeah. So screen and then DC jack. Let's see. We can use can I have one of the speakers on just to. Okay. Let's see. Oh, now fans on it. Okay, because fans on it. Let's have one of the fans. Okay, but I think speaker is enough. Should get a chime if it starts. Let's see. Okay. That's it. It's an Apple logo, and before now, as you know, we didn't have backlight. Okay, so this is quite a straightforward repair. I'm just going to do a recap. So if you have a problem like this one, just like as we saw, you have a no backlight issue, especially in boards that utilizes this form of capacitors. What you want to do is you want to check to see if you have a short on that. You can use a continuity mode for you to see if you have a short, or you can use a diode mode. So diode mode is more accurate in terms of because if you are too comfortable, if you are used to using your continuity mode measurements, you might only rely on the beep, which because if you don't get the beep, you might just assume that that is not a problem. So, but then if you use your multimeter or your diode mode, that is what you're supposed to get, which is one point something. And then another thing I also want to mention is in situations where you get a low reading on your backlight output, before you worry about the capacitors, you want to disconnect the screen. Disconnect the screen just to confirm that the problem is not coming from the screen, because sometimes you might have the short might be coming from the screen. So, and then I said it's one of these capacitors. There's no way you can confirm exactly which one is it, because the max or the signs that you will see will be underneath the capacitor, which will mean you have to remove it first. So the easy way, the way I do it is sometimes I can choose to take the individual capacitors out and then I measure them individually, and other times I just go ahead and remove the entire line, and then I remove the entire line, I measure again. And sometimes, please note that especially given the state of the board will sometimes affect the measurements that you get. But then the difference is you actually see it increasing and not decreasing. So the resistance will decrease and not basically increase. It would increase and not decrease. So the lesser resistance, the lower, the less resistance you have, the more it is that you have a problem. But you have to have the more the resistance you have, the better it is, because that tells you that the capacitors are doing their work. So that's about it. As you guys can see, now we have a backlight, and that's it. Thank you guys. I'll see you guys in the next one.